everybody, this is Mrs. Carnahan. So today we're going to be doing the 3-6 group notes. These are on page 361. If you want to pause and get that out and follow along, you can. So today we're continuing our conversation on direct variation. So earlier in this unit we put a lot of energy into modeling the cost of taking a cab in Vegas. There was an initial charge of $5.10 plus $2.60 per mile. So is this an example of direct variation? Well, I can tell you right now, because of this initial charge, this is not direct variation. The equation that we got was not in the form of y equals kx, and that is a direct variation equation. The equation that we had was $2.60 per mile plus the initial charge of $5.10. Because of this y-intercept, it's not direct variation. So the y-intercept is not 0, 0, so it's not direct variation. Okay, so remember with direct variation, it's in this form where there's no y-intercept. It's just a constant times your variable. Okay, so let's talk about, this is a painful experience that we almost all go through, buying gas. Yep, pretty painful. So do you think the amount spent at a gas pump and the number of gallons of gasoline are a quantity that vary directly? Well, if you think about it's the cost per gallon, right? You pay $0 if you have 0 gallons. So the cost will be a constant multiple of the amount purchased. So this would be yes, because you pay $0 for 0 gallons. And the total cost is a constant multiple, like the price per gallon, of the amount purchased. Okay. So let's say you stop at the local gas station just to buy an energy drink and you don't pump any gas. So how much would you pay for 0 gallons of gas? Well, you're still paying $0 for gas. If 5 gallons cost $11.10, how much would you expect to pay if you double the amount purchased to 10 gallons? So if I'm doubling the amount of gas, then I have to double the amount of money that it's going to cost. So I'll take $11.10 times 2, and we get $22.20. Okay, so that's how much the gas would cost. So how much would it be if you cut the amount in half by 2.5 gallons? So we're going to 2.5 gallons. I'm cutting the gallons in half, which means the cost would also be halved. So I'm going to take $11.10 divided by 2, and we should get $5.55. So this is a direct variation relationship because there's no initial cost of buying gas. Gas is per gallon, and there's nothing else that you have to add to that. Okay? So now let's look at another type of question. So how much would we expect to pay for 15.2 gallons of gas? So that's not quite as straightforward. So let's attack this problem using proportions, and then we'll see if maybe it's more efficient to use variation instead. So let's use our original rate is that we paid for 5 gallons. We paid $11.10. So we want to know what would we pay, so what's my pay, that's my X, for 15.2 15.2 gallons. Remember, with a proportion, we have the same thing in the numerator, the same thing in the denominator. So this is going to be in dollars. And then we cross multiply. So we get 5x equals, and when we multiply that, we should get 168.72, and we multiply 11.1 times 15.2. And then I can divide by 5, and we should get x equals 33.744. So we'd have to round that up to just 0.4. So I'm going to take that away. So that would be the dollars for 15.2 gallons. Okay. Now in the next problem, we're going to solve this using direct variation instead. So that was using a proportion, which is definitely something you can do to figure out a missing quantity with direct variation. So let's see how we can solve the gasoline problem using direct variation and see why that might be a good idea. So first, let's write the direct variation equation describing the cost of buying G gallons of gas, right? So I have the cost is equal to some constant, what we're really trying to find here is the price per gallon. So the constant times the number of gallons. So I know for 5 gallons, so if I have K times 5, that's going to equal 1110. Oops, that was supposed to be for the second part. So for number 8, we're plugging those in. And so we have 1110 equals, I'm going to rewrite that as 5K. Then I need to solve for the constant, so I'm going to divide by 5. And we get, when we divide by 5, we should get, let's see, 2.22 for K. So again, we set up this equation because the cost is equal to the amount of gallons times the amount per gallon. So that's why we set it up as that constant times the number of gallons. That will give you the total cost. And our constant is $2.22, so that means it's $2.22 per gallon. So now let's rewrite it with where the only unknowns in it are C and G. So before we had C equals KG. We now know K is 2.22, so we'll say 2.22 G. So the cost is equal to 2.22 times the number of gallons. All right, so what does the constant of variation we found describe? So what we already said, because K is 2.22, and we're multiplying that by the number of gallons to get the total cost, this is the cost per gallon. So how much would we then expect to pay for the 15.2 gallons? So I could plug into my equation. So 2.22 times the number of gallons, so 15.2. When I multiply that, I get, well, I should get the same thing that we got before, which is $33.74 for the 15.2 gallons. All right. So that's what we got before. So either way works. You could set up the proportion or you can set up an equation. Now the equation's useful when doing it multiple times. So if I'm trying to find the cost for any number of gallons, that's why the equation could be useful. All right, so I would say the equation's probably easier here. It makes it easy to quickly plug in the number of gallons into the equation. So when we do that, when we multiply, for 0 we should get 0. For 3 we should get 6.66. For 6 we get 13.32. For 9 you would get 19.98. And 26.64. And then 33.30. Okay, so check your answers there. Okay, equation makes it easier it says explain why. It makes it easier to just plug in G and just multiply. To quickly plug in values for G. Okay, so number 13 says, what would it cost you to put in 11.55 gallons in your car from this pump? So again, these are a couple more problems of finding the number or finding the cost. I would use the equation again. So 2.22 times 11.55. I would say that's the easiest way, and we should get $25.64. So it says then, now you spend $40 on gasoline, how many gallons did you get? So now I'm given the total cost, which is C. So I would say 40 equals 2.22 times gallons. I'm trying to figure out what gallons are. I would then divide by 2.22 to solve the equation for G. And when I divide, I should get G equals 18.01 gallons. Alright, so solving problems with direct variation, we first identified the two quantities that vary directly, so in that case, cost and number of gallons. Note which is the input and which is the output. You input the gallons to figure out the total cost. So then we write our equation in the form y equals kx. We have to find the constant of variation using the given input and output to find what k is. Then once we have k, we can rewrite the equation in the form y equals kx, where we replaced k with the number, so in our case it was 2.22. It might be helpful to write units on them and think about dimensional analysis. How would you cancel units to get the unit that you want? It might help us even set up the proportion first and use that to help you find the constant of variation. All right, and then use your equation to solve the problem. All right, so let's do this other example. It says, if you get paid an hourly wage at your job, the total amount of money you earn varies directly with the number of hours you work, right? So let's say you worked 14 hours last week and made $163.80. Write a variation equation describing your total pay, P, in terms of the hours worked, H. Then find it to use how much you'd make for working 20 and 25 hours. So for our variation equation, we have P equals a constant times the number of hours. That constant's going to represent your pay per hour, and that's what we need to find. We're multiplying the pay per hour times the number of hours to get your total pay. So I need to plug in what it tells me for 14 hours in order to figure out what is K. So my total was $163.80. That's my total pay. Then my constant I'm finding, H, is 14. Now that's the same thing as 14K, and I'm multiplying, so to get rid of the 14, I would divide by 14. And when I divide, I get K equals 11.7. So it's $11.70 per hour. So that would be P equals 11.7H. So now if I wanted to figure out what it would be for 20 hours, I would plug in 20 for H. And when I do that, I get $234. Now let's do 25 hours. We plug it in. 11.7 times 25. And we should get $292.50. Oops, and dollars. Don't forget your dollar sign. So setting up this equation can help us figure out how much you would make for different amounts. It also helps you find that unit rate. Hint, hint, that's our unit rate is K. We're going to skip that, did you get it, and move on to 16. So 16 says solve the general direct variation equation, y equals kx for K. So if I want to solve this for K, I need to divide by x because that's multiplication. That would cancel out the x over here, and we'd have K equals y divided by x. So So to find the constant, you can take your y over x. So what does that tell us about that fraction? So, oops, I lost it. So the ratio of y to x is a constant, right? So for any given situation, that ratio of y to x is a constant k. Of y to x is a constant. So it's just a number. So some advantages to using direct variation rather than a proportion like we did at the beginning with the amount of gas. Proportions will answer a question one at a time, but you can use direct variation to answer multiple questions very quickly. When we filled out the table, it was much quicker to use the equation than to set up a proportion for each one. With the table feature and a graphing calculator, we're not going to do this, but it does make it a lot easier to have an equation than having a proportion. You can't put that in a graphing calculator. With proportions, you never get to see the conversion factor or constant of variation. Like for the gasoline problem, it tells me the rate was $2.22 per gallon. So with the direct variation, it does tell us that unit rate a lot quicker than a proportion. All right, so let's do a couple more examples. So in this one, it says, the best gift I got for my birthday last year was my very own mini-me, not a living one, blah, 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 blah. Lots of blah, blah, blahs. Okay, so when scale models of real objects are made, here's the important part. The scale is often given as a ratio. So in this case, the ratio of my mini-me size to the real thing is 1/13. So mini-me to the real thing is 1/13. It says my mini-me is 5.82 inches tall. So how tall am I in feet? So this one I think might be easier to set up a proportion, but you can also set up an equation here because I'm going to look at this ratio, 1/13. It says mini-me to real. So I'm going to say mini to real is 1/13. I'm going to set that equal to the mini over real again to figure out what's the real height. That's what I'm trying to find. It gives me the mini-me is 5.82, and that's in inches. Now with a proportion like this, I can cross multiply to find x. 1 times x is just x, and then 13 times the 5.82 will give us the height, which we should get 75.66 inches. And it says in feet, so I need to then divide that by 12 to figure out how many feet that would be. 75.66 inches divided by 12 inches will give me feet. You can use a conversion factor, but you should get about 6 feet. And this is very in depth here. Because it's it'd be 3 inches and 2/3 inches. It's a little complicated there. We won't get into that, so don't worry about that. All right, so it says the actual mini-me from the Austin Powers movie is 32 inches tall. If he had a bobblehead made with the same scale as this person's, how tall would it be? So if I'm using the same scale, 1 mini to 13 real, the mini was 32 inches. I want to find the real. If I cross multiply, I get okay, okay. The actual mini-me, if the mini-me had, I messed that up, sorry. The actual mini-me is the real person, so 32 inches is the real mini-me. And if he had a bobblehead made, we want to know how tall would the bobblehead be. Sorry about that, I messed that up. All right, so now cross multiplying, I have 13 times x, and then 1 times 32. If I divide by 13, I should get 2.46 inches. So that would be the doll's height. All right, a few more problems here. We're almost there. Take a break if you need to and come back. All right, so number 19, it says the sales commission earned by a saleswoman varies directly with her gross sales. In 1 quarter, her commission was $72,000 on an $180,000 sale. Okay, so she sold $180,000. Her commission was $7,200. We want to figure out what's her rate. So I need to figure out how much she is making per how much she sold. And when I divide that, I get a 4%. It's 0.04, which is a 4% commission rate. So I'll put in parentheses 0.04. So let's use that sales commission rate to write an equation relating the commission earned to the amount of gross sales for that quarter. So let's make sure that we describe what your letters represent. So let's say that her, sales is S. And we could use C for commission. So we know her commission is going to be equal to the rate, 0.04, times the sale. So if I take 0.04 of the 180,000, I would get the 7,200 commission. All right, so let's use that equation to fill out the table. Go ahead and try that on your own, and then you can check your answers. I got 1,600, 3,200, 4,800, 6,400, 8,000, 9,600, 11,200, 12,800. So this is her commission for each of these sales, and 14,400. All right, so earlier we observed that as the number of rubles goes up, so did the number of dollars. We also saw that as the amount of gas we buy goes up, so does the cost. Is that always the case? So if the constant of variation is negative, what will its effect on y if x increases? So let's look at our equation, y equals kx. If I made k negative, then as x is going up and getting bigger, the y value is getting smaller. It's getting more negative. So that would be a case where it's the opposite. Okay, so if k is negative, as x increases, y would decrease because it's getting, as x is getting bigger, it's getting more negative. Y decreases. As it decreases, same thing, it would be the opposite if it's negative. All right, so let's look at a couple graphs and decide if it's direct variation. So remember, with direct variation, it just has to go through 0, 0. It's a straight line, and it looks like the only two that do that are 23 and 25. This one is not. It does not go through 0, 0. You need to look for that y-intercept if you're trying to look at a graph. Okay? Then you'll know it varies directly. It's really important to know that it's that y-intercept that causes it to be a direct variation versus just a linear equation. All right? And that's it. Okay? Again, let me know if you have any questions. Your homework is numbers 1 through 7 on the applications, so make sure you get that done.